It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
And hello, folks. Let me bring Charlie in, and
Hello.
hopefully we can hear him. Unfortunately, we've been fighting this battle for a little bit. And the subject today is how to benchmark your Postgres database. But this is something we actually need to hear Charlie on. Fortunately, we're going to have to postpone.
Yeah.
I apologize for that. We'll work out the technical details. I have support from our person for our streaming source, and they just came online and they're beginning to type me a couple questions. So hopefully we'll get a simple thing to come through. Unfortunately, without audio, I know Charlie is talented, but I'm not sure if he can do my interpretive dance or hand puppets. And I know he can't write fast enough to write this on a sheet of paper, flash it up, and then keep going.
Yeah.
So we will.
I got some papers here.
I will have to go back, capture that, and make some memes for Charlie just for that. So I apologize greatly, folks. We will redo this and reschedule it, and it'll be even bigger and better. Our tech support person, by co-present of them and guest, yes. And Charlie is unmuted. I can see that.
Yeah.
And forgive me, I'm
Yeah, weird things is
screenshot of their homepage. So
okay. Yeah.
Get that.
All right, let me get the screenshot here. Okay.
So we can get a screenshot of, I guess, that you're on now, Charlie, and we'll see and we'll try to figure out what's going on. Well, folks, I'm going to wrap this up since this is all we. He's just sent it to me. I think he probably sent it to me on. I don't know if our person can see that. Pass that. If not, I will save another copy of it.
Maybe anybody else can hear me.
These podcasts for our scintillating.
Yeah. Hey, folks, can you hear me? If you can hear me, can somebody say something?
Yeah. But we are trying to see if we can pull this out at the last minute. And
even my camera here looks weird.
Here. And with that, I don't know if anyone in the audience, maybe someone on YouTube can hear you. Let me turn on my audio on YouTube as we debug all this.
Yeah.
Let me turn on my audio on YouTube. Okay,
Yeah,
Charlie,
can you
say something, please? All this.
Yeah, I'm trying to say something. Yeah.
Okay, I can hear Charlie on YouTube.
Oh.
Okay, so we're just going to go with what we have, and I'll listen to Charlie on YouTube, and I'll mute myself on here, and we'll go as best we can. And over to you, Charlie.
Well, that's right. So that's interesting. Well, at least somebody out there can hear me, right? Well, welcome, guys. It's been a couple of minutes with troubleshooting some technical issues here. Right, so Dave was not able to hear me, but looks like the audio is going through. So yeah, we will try to make it not happen again next time. Yeah, some technical issue sometimes happens. Well, anyways, today we're going to talk about benchmarking database, right? Especially benchmarking Postgres. It's an interesting topic. It's an interesting discussion, and it's complicated. Actually, it's easy and complicated. Let's put on this way, because when we're going to benchmark something, is because usually we're trying to improve some, right, improve performance or to improve availability, all those things. So the first challenge that we have when we are going to try to benchmark is what problem we are going to solve, right? I'm sharing my screen here. Actually, I think I'm sharing the wrong screen. I want to share this window here. So you can see my window, right? So I have a very simple database here. Actually, I just installed my database, and I started when one benchmarking tool here. Just to put some data. Let me increase the font size. So usually when we go for benchmarking, we need to define what's the problem we want to solve, what kind of information we want to find out, right? Because when we go for the database is a complex piece of software, right? And it depends on even more complex infrastructure to work, right? And we can have problems, performance problems, or any other problems on the database related to many different layers when it comes to the database. And a very common one is I/O, right? So I/O is usually a very source of problems when it comes to the database, right? So one thing that we usually do when we go to benchmark is, okay, how can we improve the I/O? How can we get the I/O better, right? So then first thing we need to do is, yeah, okay, define the target, define the problem. So let's say now my problem, my database is low, and I want to improve performance, right? As I was saying, we have many different layers. So the easiest way to improve performance on database is obviously adding more hardware, right? So if I can add more CPU, if I can add more memory, if I can add faster I/O, right? So I can always improve the performance with my database adding more hardware. But there are two problems with this approach. Well, first one is cost. It's costly, right? So if we go out there, let's say we go to AWS and we are on whatever tier, we can always go to the next one. So, but sometimes just going to the next tier double the cost. And it might not be a choice, an option of putting more cost when you're doing those things. Another problem is just adding I/O has a limitation. We get to a point that doesn't matter how much more memory, for example, we add to the database. It won't get faster, it won't get better, right? So, in all those things, we need to understand if adding and more resource to the database can make any difference. So, then to be able to understand is we need to be able to understand how our database is working at the moment, how are our resources, right? So, and this is when this benchmark thing comes to the place, right? So let's say here I have this database. So I don't have any table here. Yep, no relations. No. So let me create a table. T1, a very simple table. I only put an ID with gonna be integer, no index, nothing. It's a very simple table. And what I'm gonna do is I'm gonna insert into T1, select. I'm gonna insert here a 10 million rows. 3, 1, 2, 3, right? So I'm going to insert here 10 million rows. This is basically an IO operation on my database, right? Here, my database gonna be quite an IO intensive. So, but one thing that we can do, it's very naive approach. We can run some tools like top. Right? So as we see here, I don't have much happening on my database. Let me just here before I start. So you see, CPU is almost doing nothing. It's sitting here. So the memory consumption, I have 62 gigabytes on my box here, and we're using almost nothing here on my database, right? So if I go here, let's see what happens. Well, see here that I have basically one CPU core from time to it's been switching from core to core, but I basically have one CPU core doing all this operation here. So we can obviously see that this is not an intensive operation, right? Looking at this naive approach here, I can see that, okay, if it's not CPU intensive, the memory did increase. So then this specific load here was IO intensive, right? So for this very specific thing here, can we make it faster? Is it possible to make it faster? Do we have anything on the database, any configuration and thing that we can do to make it faster before we go for better disks, for example? So those are the questions that we start asking when we start to benchmark the database, right? So those are the things that we need to answer when to benchmark the database. And that's the major things to benchmark the database. What are the problems we want to solve? I got a problem here. I have this insert that took 11, almost 12 seconds here. So how can I make it faster? All right. So I saw with this very naive benchmarking approach that's, well, it's not CPU intensive, it's not memory intensive. So one thing that I might be able to do is try to change some IO parameters, right? So let me go here to my database folder, PostgreSQL 14. So my configuration here is the default configuration, so it's very basic. I didn't change anything here. I just installed this database. So everything that you're gonna see are the default, right? Okay, I got a problem. I have an operation that is low. Using this naive approach of troubleshooting or of benchmarking, I saw that, well, it's IO bound, it's IO intensive. How can I how can I try to address this problem? Well, first approach, before we spend money, we go for the database configuration, right? So what are the parameters that we might have here on the database configuration that we can alleviate the IO pressure on my database? Well, we have a few of them. First thing is when we go to, okay, we can disable some stuff on the WAL files, right? So, for example, I might do not want to have synchronous comments. Let's disable this one. Disabled synchronous comment. Well, one thing that I'll always tell people, I've seen many tutorials on the internet asking to disable the fsync because it will help improve performance. Well, that might be true. Well, actually, that's true. If you disable the fsync, that it will help improving, especially I/O performance. Let's do this. But never, ever do this in a production database. Like not even in a test database. Don't do it for your database. Because if you disable fsync, you can really have data corruption. So there is no way to the database tell that the data is safely written to the disk. This is a very stupid and naive approach of improving performance, right? Never do it at home. So we do here because we are doing some stupid thing, trying just to prove a point, but never disable that thing for the database. Okay, I disable those things. I gonna before I do, let me drop my database. My table, drop table T1, and I'm gonna restart my database. Okay, I'm gonna restart my database. Yeah, I just restarted my database. I'm gonna just do the operation here again, create a table, and now I'm gonna do my insert here, right? So let's see what that does, right? We just did 2 changes. We changed the, well, I forgot to put my page top here, and I forgot the timing. It again, I'm gonna drop the database, I'm gonna drop the table, actually I'm gonna restart here, because I don't want anything on the database cache. Then we do for timing, we create the table, and then insert here, right? So it might get us to a few milliseconds here for this operation. And then, well, actually, it didn't improve much. It didn't improve anything, right? So this change, just in my specific case here, it didn't improve literally anything. And so, but it depends on your disk. You might get really a good performance improvement, because what happens when you disable fsync, the data will not be forcefully flush to the disk every time that you do a commit. So then it might get some improvement. But then one thing that might happen is you have data corruption, because as it's not being flushed, so corruption might happen. Right, well, there are other parameters here. We can, for example, put wall compression to make the wall, like to write last things to the wall files. We can disable some checkpoints. We can increase the max wall size. I don't think that max wall size is a problem for myself here, because it's too small, but we can, right? We can increase the wall size. So there are a lot of parameters here that we can go and start changing and troubleshooting when to improve, to change this benchmark thing, right? But one thing to note when when troubleshooting and benchmarking the database, every time that you want to change something, don't change many parameters at the same time. Change one parameter, see what happens, change another parameters, see what happens, and so on and so forth. So if you get an improvement, you know which parameter helped to get the improvement, right? So don't change too many parameters at the same time. Try to make things smaller changes, so you can always trace back to what was the parameter that you changed it that helped with that thing. Okay, so yeah, this naive approach didn't take us too far, right? So, well, it was basically trying to go here for the IO things. We can get better. We can get better, and there are tools out there that help us to get better when benchmarking the database. One of these tools is, okay, I need to save. All right. So yeah, I saved. One of these tools is Sysbench. Sysbench is a very powerful tool and works not only with Postgres, work with Postgres, MySQL, and other database. And we can even script Sysbench. Sysbench, we can create scripts in Lua. The path in my installation here is sure Sysbench. So yeah, here we can script Sysbench to do some more customized tests, or we can use the ones that has been written there. So one that we're gonna use here now for some tests is a legacy one. Include OLTP legacy for OLTP. Okay, this is another thing that we need to take in consideration, right? So the first thing, we need to have a specific problem why we are benchmarking the database. Okay, are we benchmarking for performance? Yes, we're benchmarking for performance. Do we have a hint where the problem is? Yeah. In that case, we saw the problem might be, in our case, might be IO, or might be some problems, some caching. We don't have enough memory for the database, right? Still IO related. Okay, then the next step is, how is our workload, how our application works, because there are many types of workloads out there. So the most common one are the online transaction, or OTP, right? So it's like when we have a mix of writing and reading operations. Like most of websites, what they do, or applications out there. So you have a lot of writes and reads to your database at the same time. So you have a mixed load of writes and reads for your database. Usually the reads are not so long. You don't send query that takes like 1 hour, 30 minutes, 10 minutes. So those are not common for OLTP applications. When you send a select for OLTP application, usually you want to get the response really fast, within less than a second, right? So this is very important to understand, because the load that we put on the database for our OLTP application for this type of loads is different for another one. For example, for OLAP. OLAP is more designed for reports and business intelligence and all this kind of stuff. So it's usually readings, mostly readings, almost no writes. And usually when we send a query for an OLAP application, we expect that it's a really heavy reading query and it might take some time. So the way to benchmark those different loads, they're different. The way to approach those those different types of loads, they are not the same, right? So as the most common of database out there are OLTP, we have a lot of OLTP benchmark tools. So in this case here, I'm gonna use for this example the Sysbench, right? The first thing that we need to do when doing the load is to seed the database. We need a test database, right? So I did it in advance here because it would take some time. So I created this database, and it has 24 tables. Every table has around 200 megabytes. And this is an important information. Remember, I have 64 gigabytes memory on my box. And if my database is a lot smaller, like it is in this case, than the amount of memory that I have, it can perform a lot faster than if I had less memory, right? That's another piece, part of the puzzle that we need to understand. How is our database box? How is the box itself? How is the configuration? is can the data set fit all in memory? Or is the data set a lot larger than the amount of memory they have on my database? How does it work? How is my data set? Right? How those things are being set up there? Because the results, they can be totally different. We can have totally different results. So for the same machine, the same box, with different data sets, we can have totally different values, different results. So it means that a benchmark, to be reproducible, we need to have even the similar data set. Or else we cannot compare one benchmark with another benchmark. I've seen people comparing benchmarks out there. But okay, yeah, I have the same box that the benchmark that you did. But one benchmark, the amount of data, so the data set was like 3, 4, 10 times larger than the amount of memory. Another benchmark could fit all in memory. So we cannot compare those two different benchmarks, right? It's not fair to this comparison. But okay, so yeah, I did here. So I have this, and now let's run our first benchmark here. And in my case here, I want to run it for 1 minute, right? Let's wait here. So it will connect to our database. In this case here is a read and write benchmark that I'm doing. It's not read only and not write only benchmark. So it's mostly OLTP benchmark. So it's read and write. I'm sending here, I'm asking to report every 2 seconds. I gave him a table size. So we want to make sure that our load fits in this amount of size. So also I gave him how many threads I wanted to open, because that's another thing. Depends on how many connections we open to the database. We can have more or less transactions per second or queries per second as we do. Okay, it's gone, it's finished here. And now we have a report, right? So in this box on my database, I had impressive 29,000 queries per second. So, but not so impressive transactions per second. It's like 1,400, almost 1,500 transactions per second, right? So, why might that happen? Why I could have so many reads but not so many transactions per second? So it looks like we've been impacted for something, right? Well, we can probably make things better. Let me go back to the configuration. And okay, usually a very simplistic way to improve performance is giving more memory to the database. Okay, let me give more memory to the database. So on Postgres, we have these shared buffers. And here I have 128 megabytes. I'm going to give it 8 gigabytes. So it's a lot more, right? It's a lot more. And that's the only change that I'm going to do here. I will save, and then I will restart my database. Let me copy this value here and save somewhere. Okay, I've saved somewhere. And now I just restarted my database, right? Yeah, okay. Let's run it again, the very same test. So, and let's see what happens. One thing, folks, that you need to keep in mind is those tests, those benchmarks we're doing here, they are not reflecting anything because, well, we're running for 1 minute. if we really want to understand how the database works, we need to run benchmark for a lot longer period of time because there's a lot of things that happens inside of the database. First of the things is every time that I run a test here, I restart in the database, right? Because I want my database code. So what it means, I don't want the data to be in memory from the previous execution. So it means that 1 minute benchmark would not be probably not be able even to warm up my database. So and this warming up time can impact a lot on the performance for my database. See the difference that we have here for the transactions per second, it's pretty minimal. Actually, it was smaller than the other one. Even the number of queries per second here was smaller than the other one. So what does that mean? Like, does it mean that giving more memory to the database doesn't improve anything? Like, everybody says if we can get more cache, those things, the database needs to run faster, right? And this is when this happens. So we need to run benchmarks. When we do benchmark, we need to run for, depends on the database size. Like if it's a small database like this one, probably 30 minutes benchmark would be okay to have a more accurate information about how the database is working, how the box is working. If it's a larger database with a larger box, so you can give it 8 hours on the benchmark. So the more you give to the benchmark, the better gonna be the results. The more accurate gonna be the results. Right? So yeah, we saw here that it didn't do anything. So but what happens if I run this again? Now that I haven't restarted. So let's give it one more try without restarting anything. Right? See if anything changes, anything happens. So one thing that I see here is obviously it started with 22,000 queries per second, went like around 27, 28, 28, and now it came to 30, like 31, 32, and we didn't change anything, right? So this value here will probably a bit larger than the previous value, and we didn't change anything on the database. The test is the same, we didn't change anything. So this is a reflex of the database being warming up, right? So we're given, the data is now being pushed from disk and is being sitting in memory. So we got an improvement. It was before, a huge improvement, but it has an improvement. Probably if I run it one more time, we're gonna get a bit more improvements until it gets stable, to a point that it gets stable. So that's the point that you see in your application. And that it's another thing. So if you have the habit of restarting your database every night, I've seen a lot of companies, they do, okay, no, yeah, we're gonna restart the database every night, so we want to start it fresh. It's not good for performance. It's pretty bad, because all those caches that's being warmed up, now we're just flushing and removing all of them. And then your application needs to start fresh from scratch and put everything in memory, and the database is going to be there. And this also happens to the benchmarks. So not only the database, not only the two, right? So let's come back from where we are now. So, okay, first thing first, we need to define the problem. Okay, what's the problem we want to solve? Okay, I have a performance problem here, right? So do we have a hint of what the problem might be? Yeah, we got a hint for that naive approach that probably in my case seems to be related to I/O. So can we improve the parameters? Well, we changed a couple of parameters. Can we make the load less IO bound and more memory bound? Well, we tried to. We changed the memory parameters on the configuration, right? Did we get any improvement? Yeah, looks like we're getting some improvements. Probably if we let it running for like 30 minutes, 1 hour, we will see the improvement that's happening here. Right? So those are some of the pillars when we're doing the benchmark. Okay. Nice. Okay, what can we do from here? What are all the things that we can change here on the database side? We can change anything. Right? So we can change anything. We can, for example, change the temporal buffers. Okay. I want 84 megabytes. Right? Or in our case, for now, workman shouldn't be a problem. Let's just change another parameter. I don't want to mess up with vacuum at the moment. Okay, fsync is on. Synchronous commit is off. Oh, I don't want full page writes. Oh, while it's in some circumstances it's needed, especially when we have a crash or we want to do a PG rewind, if I'm not mistaken. So for now, I want to make the writes a bit faster, and I want to write the database to write less because Postgres has a huge problem of double writes. Every time that we do a commit, we send data to the database to Postgres. When we do a commit, it needs to go to the WAV files. And then from the WAV files, then it's copied from the WAV files to the page files, like the tables itself. So this is a double write, right? So there are some ways we can try to reduce the impact. One of them is do not have full pages. Well, it might have a problem if we do not have a good hardware, or in some crash circumstances, it may make things harder to recover. But it definitely can, it will reduce the number of writes from the database. So it will reduce the impact of full page writes. Let me make it better here. Well, we don't have log hints, so we already have wall compression that's been from before. And the checkpoints. Okay, but before we mess up the checkpoints, let's see if that does anything. And again, we started the database, we're getting cold again, so probably the first run here we may not get much. Then we start again from 26. Oh, but looks like that did something. Those values are already the same as the second run we did before. Right? So looks like those changes, they're getting some improvement. We're running. We're going to looks like we're going to the right way. And the thing is, because we understand the problem we're trying to solve, or it's not only benchmark, but we do understand, we sort of understand what is causing the problem here. In my case, in this very specific case here, we can see that the problem is sort of related to the I/O operation. So we are trying to minimize the impact of the I/O on the database. And that's why we are getting some results here. See? The first run, we just got as we had the last one. And the database, like it's a cold one. Right? So we're getting there. But I said didn't want to restart. Actually, I didn't. But we also can play with the checkpoints. Right. So I have checkpoints at 5 minutes. Well, it will not impact here because we're running 1 minute. Again, see that's how it's naive to run only 1 minute a benchmark test. So we cannot even from the default configuration even see what happens when we start checking points because of checkpoint timeout. Because our test is happens in less than 5 minutes. It's 1 minute, right? So when we do benchmark, we need to properly prepare for a long run benchmark. As I said, leave it run for 2, 4, 8, 12 hours. Right? Leave it run at night. When you go back in the morning, we'll see the results, right? But anyways, so yeah, this here will not make any difference. So 30 minutes, or maybe it does alleviate something because it will make the checkpoint more sparse, even though we're right now. Yeah. I'm gonna leave it the default here. And my maximum size, because of we have so small load, it's probably not even getting to 1 GB. Let's change it, right? So we're here ready. So we do not have archiving because I do not have replication here. It's just, and okay, no recovery, replication. We don't have anything for replication, so it doesn't matter here. Still on the replication. Okay, for now, we don't need to do any query planning. And all right, so we are not logging anything. This is something that can impact performance. Log is very important. But if you have your production database, you write a lot there. And depends on the verbosity of your log, you can get huge performance impact. So I'm going to just restart my database here. We'll see that the last change we did will do anything, right? So probably going to be the same, around that 39, 30 seconds. And after this run, I'll enable the log. I'm going to try to make it variables. We'll see the impact, even probably in this small run here, test here, we can see that it can have some impact. This is something that we need to keep in mind. If you need logging, you need to make sure that your login facility you are sending to a BitLog facility that it buffers the log. So it gets back to the database really fast, and then it flushes asynchronously instead of just sending the log to the system facility. That's going to try to flush it as fast as possible, right? Yeah. And we didn't, as expected, we didn't have any improvement because, well, just 1 minute is not enough. So I'm gonna enable here. I'm gonna send to the log directory. Another file name. I'm gonna put rotation size 1 GB, 1 GB. I don't care the truncation now. Okay, I'm gonna want to put it variables. From one point, I want the bug 5. Let's put this as verbose as we can. And yeah, again, bug. Let's log everything. Everything. all statements. I'm making it really, really verbose. Oops. All vacuums, checkpoints. I think that should be enough, right? Anything else? All right. Log statement all and login types. Okay. Okay, I enable all the logins. Let's restart my database. No, I want to restart my database. But before, folder name. Let's make sure. Oh. Okay, let me restart my database. And let's do our sysbench. Let's see how that impacts. Oh, look what happened. I think we got some impact here, right? So from 30,000, now we are down to 10,000. This is the sort of impact we can have because of I/O, and in my case here, because of logging. Right? It's a humongous impact here. So that's happened to my database because I'm logging like crazy on my database here. Let's wait to finish to see the final result and see how amazing that's going to look. It went to less than 1,000 queries per second, 500 transactions per second, and 1,000 queries per second. It's amazing how we cannot only improve, but how we can improve a point that having too much log is really harmful to the database performance, right? And this happens to the same when we have a huge query it's writing a lot of template files. So every time that we make our load IO bound, in my case now it's IO bound, and it's not because of the database, but because of the logins, the performance is going crazily down. And well, my IO is not that bad. Like, well, it's an SSD. It's not an expensive SSD for, like, it's not a server grade SSD, but it's still SSD, right? And you can see how amazing the performance went down. And this is one thing that we need to be very careful, right? Well, those are things that we can do, like when we are benchmarking. So we need to follow some of those basic rules. We need to know what we want, why we want to benchmark, the reason why we want to benchmark, what is the problem we try to solve, the approach that we have. So, and then as I mentioned, there are many toolings out there, right? And here, those examples I was using Sysbench. But we can, there are other tools, we can use other tools. Like, for example, here, let me get here. Is this? So, oh, it's not sharing. Oh. Interesting. Okay, can you guys see my screen here? So we have other tools out there as well. So we have specifically for Postgres PGBench, and we can find some documentations on the Postgres wiki here. So also on the Postgres documentation, we can find some things here. If you go for Percona blogs, we'll see some blogs about using tools like Sysbench, the one I was using here. Also using PGBench for some sort of other benchmarks. Another tool that it's amazing. It's really nice. You may take some time to understand how it works. Is HammerDB. Let me see if I'm able to get HammerDB working here. Just to show you. So HammerDB has this nice interface. Let me share here. Window HammerDB. Okay. So HammerDB has this. My sharing capabilities here is having problems today. Yeah, we're having a lot of technical issues here. Okay, can you guys see my screen? Okay, I think now you can see. Okay, so this is HammerDB. I create a basic test here. Yes, right. Let me open this test file. So this is HammerDB has this nice interface here that we can use to run some tests, and we can also use the CLI interface that we can script and automate and everything, right? But if we just let me change the number of virtual users here, then it's fine. Okay, I dropped my database, so I need to build a schema. Let me build a schema here. Warehouse. Let's build here a schema. All right. So it's building the schema. It'll take a couple of probably 1 or 2 minutes. So HammerDB, it's a very good, especially if you want to go for TPCC type tests. So it's really powerful. It works using the notion of warehouses, right? So the company can have one or many warehouses when we have our products in there, and every warehouse can work with one or any customers, so and one of any deliveries, and every deliver or every order is what the HammerDB gonna start tracing. It's not only about transactions per second, not only about insights per second, but like orders and the whole operations per second. Is something closer to how the application would work. Right? It's very interesting the approach that they use, and so it's really nice to hear. And as I mentioned, so we can script it has a nice CLI, and or we can use the graphical interface. In my case here, let me see, I have how many, okay, virtual users. And I'm gonna run here for 2 minutes. We don't have that much time anymore. It also has, if you see here, it also has the ramp up time. So you're gonna try to do some warm up. right? So I'm gonna create here, and then I'm gonna run. Well, we can see how many transactions per minute, how many operations per minute the database is starting to do, right? As it will update here every 10 seconds. So in my case here, I'm running 31 virtual users. So the virtual user is like the application that doing the order is the user, the person that goes to the internet to buy your stuff, right? This is how it works. And we can see here on real time how that are working. And after finishing, we also will see here on the monitor how it will show how it presents us the information here. All right, let's give it a couple of more minutes. We are about on the top of our hour, but as we had some technical issues, I think we can go a couple of minutes further, right? So that should be fine. And okay, it just finished with the warming up, the ramp up. So it's now doing the transactions. Don't get impressed with those numbers because those are transactions per minute. If we get a calculator and divide 229,260 by 60, we're going to see that we have 3,821 transactions per second. So that is somehow compatible with the information we got from Sysbench after we enabled that amazing login, remember? So we're not expecting to get a lot better here because, well, the logins is still hurting the database performance, right? I do not expect to get anything even closer to 250,000 transactions per minute, right? That would be around 4,000 transactions per second, right? Because, well, we did an amazing job of putting contention to our database. Okay, it's almost done. One more minute. Well, and it's almost there. So while it's finished, let me wrap up here what we were discussing. Yeah, it's gone. So here it's what we see. An average of transactions per second, right? And as I said, it's an amazing tool. Sysbench, not Sysbench, Sysbench as well is another amazing tool. But depending on how you want the type of test you go to your database, you probably want to go for HANA TP, right? So it's an incredible, it's an amazing tool. But to wrap up here, so a benchmark is a very powerful tool, like benchmark the database or benchmark anything else. It's a very, very powerful tool. Like a question that we have here: can we run a benchmark to test a new hardware? Yes, we can. Right? Actually, it's advisable. Not only that we can, I would say we should. Like every time that we get a new hardware, every time that we get something, we should benchmark those hardware. And there are many different types. When it comes to hardware, there are many different types of benchmark, right? There are specific benchmarks for their hardware. So we could benchmark the disk. So we can bypass the OS cache. We can benchmark the memory performance, where instead of bypass the OS cache, we write a lot to the OS cache. We can benchmark CPU, so we do a lot of CPU operations. So we understand how the new hardware performs better or worse than the old hardware. And remember, a new hardware does not necessarily mean that it's gonna make the database runs better and faster as the old one, right? But yeah, if the hardware is better, it's a high chance that things gonna be better. But yeah, we should definitely benchmark when we get new hardware. So, but as I mentioned, like wrapping up, so it's a very powerful tool we can use for the database. Like when I say powerful tool, I mean benchmarking is a powerful tool we can use for the database, we can use for the hardware, we can use for the OS, we can use even for the network, right? And when we define the specific problem we want to solve, the specific problem we want to benchmark, so we have those guidelines, then it's easier to get more accurate information, right? And remember, if you're going to benchmark, don't do 5 minutes benchmarking. Maybe not even 30 minutes benchmarking. Leave it run for a couple of hours. So let your database or your hardware to show what it's capable of, right? Because it needs to up. It needs to, in case of the database, it needs to up the cache and all those kind of stuff, right? So, and you can have a huge performance difference in both sides of good performance, because now it's putting a lot of things on the cache, or you can see how you can hurt the performance with the checkpoints, for example, right? So, and those things, they don't happen in 1, 2, 5 minutes benchmarking. You need to leave the benchmark to run a lot more. Well, thanks, folks. Those are the things that I wanted to share. We went up to top. Well, it's not the top of an hour, but like we had the troubleshooting in the beginning. So I think those 5 minutes extra here it's fair. Thanks again for being here. I hope you enjoyed, and that's it. Thanks, Davey. It's with you.
Well, thank you, folks. Thank you, sir. Have a good one, folks. And we'll be back in 2 weeks with another talk with Charlie. So have a good day.
Thanks, everybody. Have a good